Morning. Happy Monday, week 12. We're going to be talking about naming ionic compounds. Our learning target is to use the periodic table to determine the chemical formula of an ionic compound. And we can name monatomic, mono means one, ionic compounds, and distinguish between monatomic and polyatomic ions. Why do we need to learn this? The proteins we need, the carbohydrates we eat are a result of chemical bonding because between atoms. The oxygen we breathe is a result of chemical bonds. The gasoline we use to run our cars and do so thanks to the chemical bonds and chemical reactions. Chemical bonding occurs around us and is necessary for survival. So we're going to do this by watching the video recording. We're going to talk about this and use a Pear Deck. So happy Monday. You can do this. Believe in yourself. This is challenging and you might hurt your brain a little bit, but that's okay because that means you're learning stuff. If this was really easy for you, it didn't take any effort. You're not learning. This is stuff you already know. All right, so get out your work for extra credit. We're talking about some vocabulary. Hydrogen bonds. So a strong attraction between hydrogen atoms. Okay, so it's like intermolecular. It's an intermolecular between the OH and an oxygen. So here's a molecule and another molecule. So if I get this molecule here is bonding. That's why they have these dots to the O in the other molecule. All right, so this is intermolecular. It's a weak bond, but it's this OH and an O. Sorry, an OH and an O, or H and an O. Right here, see HCl, it's not an OH. So there is some intermolecular bonding going on here between H and Cl, but it's not this hydrogen bonding where you have the OH. All right, metallic bonds, electrostatic attractive force between negatively charged valence electrons. So here are the valence electrons that are in between the protons of metal ions. Okay, so we talk about them being delocalized or a sea of electrons. They can move around freely and be used by all of these. Okay, so the metallic bond is the bonds of the same type of atoms together, all the same atoms, but then the valence electrons are free to move around. So the electrostatic force, so that's like an ionic bond between negatively charged, and the positively charged protons. So a non-example would be this hydrogen bond. In some atoms are organized, atoms or ions are organized. So crystalline compounds have organized by atoms or ions. Non-crystalline form organized by atoms have unorganized atoms or ions. So kind of a clump we talk about there. Crystals are atomic structures that have repetitive patterns and the distinct shape repeated over. Unit cell used in the repeating pattern is in the crystalline formula. So let's take a look at this video here. You can see that there's no sound in this one, that the silicon repeats the pattern, so they kind of form in this structure where it's regularly shaped. Crystals consist of many alternating positive and negative ions bounded together in a matrix. So this is a shape. Ionic crystals form as a result of three-dimensional attraction between ions in the compound. So here is that bonding, how they bond. So many compounds form molecules, but not ionic compounds. They form crystals. So Sodium chloride is a formula with one Na atom, gives one electron to the Cl atom. Ions are formed in the exchange at a 1-to-1 ratio. The ions then arrange themselves in repeating patterns. So here is this repeating pattern here.
When we're talking about the structure for NaCl, we're normally talking about a crystal. And a crystal is made up of a bunch of repeating formula units, also called unit cells. So a formula unit for NaCl might look like this here. So the sodium lost the valence electron to the chlorine. It lost that electron, it became positive. Electrons are negative, so the chlorine has an extra one, it now has a negative charge. And that positive and negative, they attract to form the chemical bond.
So this is how we write these, the Na plus and the Cl with the brackets. Important to know that.
When we're talking about the structure,
So reduced to the smallest unit ratio. Sodium ions counted 3, chlorine atoms counted 3. We reduced 3 over 3 to 1-to-1. So here is your crystal formula of where they're put together. So we have Na and Cl repeated. So we use this NaCl ratio of 1-to-1 instead of 3-to-3. MgCl2, so we've got an Mg, and we have 2 electrons of Cl, 2 ions of Cl. So we have a formula. Here we have 48 Mgs and 24. I have it the other way around. Yeah, 24, and so we can reduce that to 1-to-2. So oxygen, so what we do in this particular case is we find the valence electrons, so -2 for oxygen and magnesium +2, okay? And we write them as a subscript, but when they are the same number, we reduce that to 1-to-1, MgO. Reducing a ratio means converting the ratio to the simplest form, 2-to-4, 3-to-12, 2-to-10, 6-to-18. So this will be reduced to 1-to-2, 3. This is 1-to-4, 1-to-5. This is 1-to-3. So 6, we can divide by 6 on each side here. So 6 over 6 gives us 1, and 18 divided by 6 is 3. You can divide 2 by 2, and 2 by 10 gives us 1-to-5. All right, so sulfur and magnesium. So sulfur has 6 valence electrons, and magnesium has 2. We reduce the ratio. Okay, so reducing the ratio, Mg2 and S minus, Mg2S2. Reduce the ratio, 2-to-2 is the same as 1-to-1. So we get MgS. So naming this formula, we always name the first metal first. We call this magnesium, and it's a chlorine, so we change the last to IDE, chloride. write the symbols, write the charges, cross over the charges, remove the charges, simplify, and remove the ones. So cations and anions. Okay, so we have calcium 2 Cl2. So two calciums. The calcium can give 2 electrons to the Cls. So that makes them 8 electrons each, so they're full. The barium is a metal, gives up 2 electrons to the oxygen, so it's a BaO, simple. K2, potassium has 1 electron, so you need 2 of those to fill a sulfur to give the 8. And Fe has 3 electrons, and bromine only needs 1. So you can attach 3 bromines to that. And then chromium, you can add 3 oxygens to.